Good morning, good afternoon, good evening to everyone. So already I think Dr. Cyril has covered many of the things in the insight into Risk 5. I will be concentrating on A and ML space applications. So quick introduction because we have less time. Quick introduction to A and ML and some space applications. Already Vasam sir has explained many things. I will point out one or two more things here. And key issues in A and ML which can be resolved by Risk 5. This is the key thing, and then we will conclude quickly. So if you look into the A and ML history, it's a long history. Many people think it's a recent one, but in 1642 itself, a small grain-like thing started germinating as the French scientist Blaise Pascal and other people started working on mechanical way of calculation, because calculation is one of the fundamental things for the human nature, and they wanted to mechanize it. So a lot of things started, but if you see that actually in 1955, much before I was born, so the term AI was coined in some conference, and then many things happened. But in the year 1997, this is one of the very important year for us, because all the A&ML people, first time in the history, we were able to beat Kasparov, the great grandmaster of chess. The IBM's Deep Blue was able to beat him like this, and also in many other people. So the question is not any longer competing with the human beings, surpassing human beings. This is the state at which AML is currently there. So put it in a nutshell, normally in the traditional programming, you write a program, give an input, and then your computing system calculates and gives an output. But in the case of machine learning, you expect an output and you say that this is the training data set I am giving. My system learns on its own and gives me some logic or some learning. So this is the real change that has happened in the computing phase. So the data set becomes very crucial for us. Supposing that if I want to compute 0 power 0, we know that anything power 0 is 1, 0 power anything is 0, but what is 0 power 0? Not a nice problem to work it out with ML. Just to tell you what is the impact of a data set. This is very, very key for us. So if you put 1 power 1, 0.9 power 0.9, you see that the value is reducing. You feel that maybe 0 power 0 is 0, but that is not the case. If you move a little more, 0 power 0.3 power 0.3, 0.2 power 0, go on reducing, it goes to somewhere 1. Actually, if you look into it, it is indeed 1. Okay, so 0 power 0 is 1. Mathematically also you can prove it. Limit x power x, x tending to 0 is 1, those who know mathematics. So the key point is to what level of data set you have to go to get the right answer is a key for ML. So now the data set becomes a big thing. That's what exactly ChatGPT did. If you look at into 2018, when GPT, that is generative pre-trained transformer model, was introduced, they had only millions of parameters. When ChatGPT 3 was introduced in 2020, it was in billions. And in the case of GPT-4 in 2023, in a matter of 5 years, it was trillion. Look at the data sets. Look at the parameter, orders of change that is happening. That is what made the generative GPT model very, very effective. But a lot of other applications are there. Recently, there was a large, it was somewhere around trillion ton. It's not a small weight of iceberg which detached from the Antarctica and then entered into the ocean. Huge amount of things happened, but this was one of the applications, space applications, where which we started detecting the fissures very early, and the rate of fishing, that is also we have looked into it. Now currently, NASA has come out, NASA and EU also has come out with the digital twin of the Earth itself. No longer it is a machine or some mechanism. The digital twin of the Earth itself is now available. Many experiments, including climate change and other things, are carried out now. We can actually expedite what will happen. For example, 1 trillion ton of ice has moved into the ocean, what will happen? We need not to wait for this thing. We can expedite these processes in our testing and get much better results. Really, ANML has been used in India. If you see Chandrayaan-1, detected ice or water on the moon, but there were some thermal corrections which have to be checked. So in Chandrayaan-2, that's what you are seeing. This is the ISRO facility in which Chandrayaan-2 is there. So that after doing a lot of ANML things put in, it confirmed the water and ice on the moon. So a lot of real applications of ANML already have been accomplished. It's not that we are going to start it. And this is very nice one. I like it because moving in the spacecraft, literally you are floating, reaching out to equipment takes time. So now they have found something called as a floating Alexa. Just you need to call Alexa and then it comes to you. You say, increase the temperature there, decrease the pressure there, move the antenna here. Many things you can give a voice-based applications. Very useful thing that what we have. So this is that one what is here as a balloon is the one that is doing all these things. Amazing things also happen. First time we were able to fly a drone over Mars. Actually, this is very tough thing. Those who know the atmospheric pressures and atmosphere, first of all, they are thin atmosphere there in Mars. And again, communication, distance of communication between. First time, apart from the Earth, first time we were able to fly a drone on the Mars, collected so many informations, all happened through many of these things. But ANML has its own problems, leave alone all these things, which can be solved in Risc-V. The problems is related to ANML solved by Risc-V, I'm putting it. Lack of data, especially as I told you, data is a key thing in ANML. Ethical issues. There are a lot of things, how to steal an ATM and all. You cannot put it in the chat GBT. It will cut and say, no, we're not going to give this information. And all we require is, as I told you, billions and trillions of parameters are there. We need to make a fast computation of this. Again, biases are always there. But these three things, scalability, explainability, low power requirement, these are something provided very nicely by Risc-V, and that's why we are looking into it. Just to give you an example, in the gigaflops per joules, if you see, Risc processor requires very, very less joules. So this is one of the things which is very, very attractive for us. Secondly, I think Dr. Cyril also put the same thing, but the key point is here. If you look into it, the implications of Risc-V is very low, but then it is exponentially increasing. The market is accepting the Risc-V, especially in the industry sector. Especially in the industry sector, it is growing phenomenally well. One other thing as a computer science people we love in the instruction set architecture is that always to go to hardware, we were going only through operating system. And now we have the instruction set architecture, which is encompassing this hardware, and directly the compiler and the assembler can access this thing and get into the hardware. This is one of the key things that what we have. Very nice things. Again, going back into some of the accelerators which are already there. These are the examples which are providing modularity, extensibility, openness, doing some of the complex operations like convolutions, large matrix manipulations, all done very well by Risc-V. Again, one of the other thing, edge computing, because lot of satellites, lot of observations, we need not to pass all the data down to the earth for computations because the communication cost is involved. Huge data has to be transmitted. We want to compute it in the edge itself, just near the sensor. So Risc-V is also giving lot of advantages. Already lot of chips are there in the doing edge computing using Risc-V. Coming back to the thing, processor for the satellite data system architecture. If you look into 1980s and 1990s, very slow CPU, something like a single chip processors, 14 MIPS at 20 megahertz was there. But then 1920s in satellites, data processing ones. Onboard computers came, but they are not very intelligent. But Risc-V could be a choice. I'm sure it will be the choice. The non-standard instructions for bit manipulations, even at the level of bit, Risc-V is able to do an optimal number of pipelines, including for interprocessor communications and other things, can be done by Risc-V. So this would be a processor of choice. So concluding this, yes, A&ML requires optimal performance from the hardware. Yes, that is one thing which is required. We have a lot of nice models, trillions of parameters are there, but then yes, they can, many things are there in the space application, like Vasan sir has said, what are all the things that can be done in these space applications. But key point is Risc-V could be one of the key processors which can be used in all these things. Thank you so much.